this little project, I'm going to take a standard cheap multimeter that you can get for just a few pounds, and I'm going to turn it into a very handy CDI diagnostic tool. And this is how I'm going to do it. Well, it looks to me as though it's held by just these two screws here. The crossheads. I thought there had been one up here somewhere. Anyway, they must be the ones you take out, because how would you change the battery? Come on. There's always one. There it is. Ah. Oh, I see. There's two little lugs at the top that engage in the top there. That's why they only have two at the bottom. And it uses a PP3. Well, there's not a lot of room in there, is there? 3/16 over the board and 3/8 max over the display. Well, if that's what we've got, that's what we've got. We'll cram it in there somewhere. Should be interesting. Right. Don't panic, guys. I've carefully measured. Having said that, we ain't got a lot to play with. Gently, gently. Don't let it bite. All I need to. Oh, that was a bit of precision drilling just in that bottom half, and that's going to be the peak voltage reading from the CDI. Right, onwards and upwards. Purchase some cheap test leads and carefully measure the diameter of the lead, and drill two corresponding holes in the top of our meter, being careful to avoid the LCD screen and one of the lugs this side. Chop those plugs off the end of our leads and bring the negative one, the black one, in this side, and bring the wire all the way down and solder it to the bottom common connection. This little buzz bar here is a 10 amp shunt for the meter. We could have soldered on there, but I'm going to want that for later. Bring our red lead into our meter and super glue, or hot melt glue in my case, to the case so that it doesn't get pulled when we break the connection. And then between the red lead and the switch we need an IN007. The cathode goes to the switch side and the anode goes to our positive probe. Next we take a 22 microfarad 400 volt working capacitor and we connect it between one side of the switch and our common buzz bar. The side that goes to the switch is the positive of the capacitor, and that's the longest leg. The shortest leg is the negative side. Here I've taken a 1 megohm resistor and I've bridged the capacitor from the switch to the buzz bar. And here, just to make a neater job of it, I'll put a piece of sleeving over the wire and the resistor. Next we take a jump lead, this blue lead, we make a connection here and we bring it down to our second one up on our meter. And finally the last component is this resistor, which should be 300 ohms, and that's soldered across the switch. Here I've used 270 ohms because that's all I had. Okay, well, a practical test now to check that everything is as it should be. If we take the voltage in the UK, let's say 240, that's RMS value. It's not peak. So we multiply that by 1.343. It gives us a peak of 322 volts. So how does our little unit compare? Well, if we switch it to the highest range, 1000 volt range, on the DC scale, that is what I said, we should see 320, 23, 24. That's pretty accurate for a cheap old meter and a few components. An interesting feature you'll notice, if I turn off the mains, you'll notice that the readings will slowly drop and they'll go to 0. And that's our 22 microfarad capacitor being discharged by the 1 megohm bleed resistor across it. For the perfectionist amongst you, you can tweak that a little bit, but I wouldn't recommend by more than 10%.